Today we're going to be looking at dividing polynomials. Our first example is 9x squared plus 6x divided by 3x. We rewrite those each term 9x squared over 3x plus 6x divided by 3x. Looking at each term then, 9 divided by 3 is 3. X squared divided by x is just x. Plus, which is from here, 6x divided by 3x, well, 6 divided by 3 is 2, and x divided by x is 1. So 2 times 1 is 2. So our answer is 3x plus 2. Our second example is 8x to the 6th plus 6x cubed divided by 2x cubed. Again, we rewrite each term over 2x cubed because we are dividing by 2x cubed. 8 divided by 2 is 4. X to the 6th divided by x cubed is x cubed. 6x to the 3rd divided by 2x to the 3rd. Well, 6 divided by 2 is our 3. And x cubed divided by x cubed is 1. So 3 times 1 is simply 3, which gives us our answer of 4x cubed plus 3. Our third example is 12a squared b squared plus 6ab minus 2a, all divided by 2ab. Again, we'll rewrite each term over our divisor, which is 2ab. So when we divide 12 by 2, we know we get 6. And if we have a squared divided by a, we get a. B squared divided by b is b, plus 6 divided by 2 is 3, and our AB's cancel out. We have minus from up here, this minus. 2 divided by 2 is simply 1. A divided by A is simply 1. So we have 1 on the top and just B on the bottom for a final answer of 6AB plus 3 minus 1 over B. Our next example is x squared plus 5x plus 4, and we're going to divide that by x plus 1. And we do this by long division, so I have x plus 1. I'm dividing that into this x squared plus 5x plus 4. When you do long division like this, you're always working with this outer term, and you say x goes into x squared how many times? In other words, what would it take times x to get me x squared? Well, we know that's x, so we put an x here. And then we go x times x is x squared, and x times a positive 1 is a positive 1x. We subtract that whole quantity, and the x squareds go away, and that should always happen with your first term when you're doing this long division. And if we have 5x minus 1x, we're left with 4x. Then we bring down this positive 4, and we go back up to this outer x that I told you you're always working with, and you say x goes into 4x how many times? Well, it's 4, and 4 times x is 4x, and 4 times 1 is 4. And again, subtracting that whole quantity, when we take 4x from 4x, we're left with 0, and again, that first term should always go away. Minus 4, in this instance, the plus 4 and minus 4 go to 0. So that means that this x plus 1 times x plus 4 gives us this x squared plus 5x plus 4. Doing another example, a little different with negative signs in it, we have 9y squared minus 3y minus 2, all divided by 3y plus 1. Again, we're going to be doing long division. We're taking 3y plus 1 into this 9y squared minus 3y minus 2. Again, we're always working with this outer term, 3y in this case. 3y, what does it take times 3y to get me my 9y squared? Well, of course, it's 3y. So 3y times 3y gives us our 9y squared. 3y plus times plus 1 is plus 3y. Again, we subtract that quantity, and our first term goes away, and that's what we wanted to do. 3y times that 1 gives us that 3y. It becomes a negative, though, so we have a negative 3y minus 3 more for a total of a negative 6y. Bringing that negative 2 down, we go back up to that outer term, pick up that 3y, and we say 3y times what will give me this negative 6y? Well, of course, that's negative 2. A negative 2 times 3y is a negative 6y, and a negative 2 times a positive 1 is a negative 2. Again, we have to subtract that quantity, and when we do a negative negative, this guy becomes a positive 6y. A negative 6y plus 6y, that first term goes away, which we know that's what we look for. Minus minus 2, in this case, the 2 also goes away, which tells us that 3y plus 1 times 3y minus 2 would give us 9y squared minus 3y minus 2.